Let's begin this course by studying one of the simplest software design principles called CQS. But before looking at the meaning of the acronym CQS, we should ask ourselves, do we really know what the concept called encapsulation is? Perhaps in a course you have taken in school or in an object-oriented programming course, you have heard this term. Personally, I have heard some developer colleagues who have a partial understanding of its meaning. Let me explain. Normally, encapsulation is related to hiding information of an object, not showing all fields or variables of them. Similarly, it is said to involve creating properties to expose information in some programming languages and using getters and setters in others. However, encapsulation goes a step further. It is about API clients not having to know the internal workings of a system in order to use it. We see examples of encapsulation all the time. For example, when using a car. Manufacturers do not give us a complete guide on how each component and part of the engine or the car itself works so that we can use it. Instead, we just need to focus on learning how to interact with specific parts, such as the gear shift, steering wheel, air conditioning buttons, among others. Or, for example, when using a search engine, we don't have to worry about the search algorithm to use or selecting the most convenient server for data access. No, the user just needs to know how to enter information into the text box, and that's it. What is the common point of these examples? Well, the simpler the way users interact with the system, the faster they can use it to their advantage. This is exactly what happens in our systems with our code. Have you ever experienced that after a few months you come back to read your code and you don't understand what some methods are for at first glance? To the point that you have to examine the code to understand it? Or that in the company where you work you have to take on a code project that someone else has done and you lose several hours trying to understand what each of the methods in the classes does? Let me tell you that it is very normal in software projects. And it usually happens when there is a lack of empathy when writing code. This might sound a bit strange, being empathetic when writing code. Most of the time, this is not done on purpose, since realistically, we are paid to write code, to provide solutions to problems at the moment we are in, so that it is the only interest we have at some point in the projects. However, after taking this section, you will understand how with a few simple changes, you will be able to significantly improve this empathy for your fellow developers. There's even a humorous saying that you should always write code as if the person who is going to maintain it is a violent psychopath who knows where you live. Why is this a problem? You might be wondering. Well, the reason is that, as we saw earlier, when we write poorly written code, we developers can end up spending a lot of time reading the code and trying to understand what the different methods in a class do. This is extremely unproductive since you can end up reading up to 20 times more code than you write, which, as you can imagine, causes delays in project timelines. What we should always strive to do is to write code or APIs that are easy to understand as soon as we read their definitions. That is, at some point we know a lot about a business topic, for example, and we want to represent it as quickly as possible in code. But we should always try to do so in a way that other developers or even ourselves can understand these definitions as quickly as possible, without having to examine the source code of each of the methods, or at least doing it in the shortest amount of time possible. As I know you love to read code, let's take a look at a practical example of unempathetic code. Here I have a project that I have developed previously. It is a very simple project, and I have here a class called CSV Manager. The idea of this class is that we can manage files in CSV format to carry out a set of operations. At first glance, I ask you, could you tell me what each of these methods that we are currently seeing on screen does? The code in question does not contain any coding problems in terms of syntax. As we can see, we can compile the solution without any problem. Here we have a successful compilation, but again the question arises, can you tell me exactly what each of these methods does? And if you say yes, the first question I would ask you would be, why, as part of this method called save, Do we return a string? Perhaps the set of records that we are passing to create this file is being returned in a string format with some commas, for example? Or maybe some error message is returned in case there is a problem when trying to create this file? Or perhaps this ID that is being passed as part of the parameters is returned in string format? The truth is, this is not easy to guess. We cannot easily guess what exactly this method does. You might think that documentation exists for this purpose, and the truth is that it does. Documentation can help us in most cases, but there are projects where documentation does not even exist, or it may be incomplete or outdated. And surely, the next step you would have to take to find out why a string is being returned as part of this method is to precisely expand the implementation of the method called save. We can see the implementation. We see that we are forming a path here by combining a folder from the CSV folder property, and we also attach the ID with the CSV format to form some kind of combination for the CSV file path. And then, through the use of an external library, we carry out the writing of a set of rows that were passed, which in this case is a set of a list of people. And at the end of this method, we have this return, which returns the path where the file we just created was created. You might think that this is not a big problem because it's just a few lines of code, but imagine that you are working on a larger project. You have a project with hundreds of lines of code, and you have many methods, and you have to examine them one by one to know what each of them does, since they have this format where you don't know what is being returned in each of them. Even imagine that you have a set of calls within the same method, which make subcalls to other methods to perform some processing, and in the same way, you don't know explicitly what each of them returns. Now, let's examine the following method, the method called read. Can you tell what this method is doing? Surely, with your experience, you can guess that any method called read would return information in one way or another, but in this case, we cannot know what this method called read is returning to us. If you have a little more experience in the field of programming with C# and you see this event handler that we have at the top, you might get the idea that this event and this method called read are related. And if we look at the definition of the method called read, we see that indeed a specific path is read. And also as part of the method, we see that this event that we created earlier is precisely being invoked. And a set of arguments is created containing the information of each of the rows that were read from this CSV file. When reading a file is carried out, this event is triggered, which notifies each of the instances subscribed to this event to carry out processing or some type of processing of the information that we have read. In a larger project, we probably would not have had this event immediately or at the top of our method. We likely would have had this event in the part of the definition of the fields of the properties, and it would not be so easy to intuit what this method called read is doing, or why it is not returning a list as we might have wanted. This is an example of code that is not so friendly. It is an example of code that is not empathetic, because it cannot give such exact information to other developers about what exactly each of the methods does, or why sometimes a certain type of data is returned, because sometimes it is not returned. What we're going to try to solve through the principle called CQS. Bertrand Meyer is the author of the book called Object-Oriented Software Construction. In his book, he makes the following statement: every method should be either a command that performs an action or a query that returns data to the caller, but not both. Although this may sound very focused on the area of databases, the assertion was written with the object-oriented language called EFL in mind. Next, we will explore what commands and queries are all about. Let's start by analyzing the queries. As we have said before, these types of operations return some kind of information, which means they do not modify the state of a system in any way. Among the main characteristics of queries, we can indicate that the returned information do not change or affect the state of a system, are idempotent operations, meaning they will always return the same type of result without affecting the system's state, no matter how many times they are executed. Being simple query operations, they are safe operations. Let's look at the first example of a query. We have here an example written in C# code, but the same applies to any programming language. This method is returning a set of addresses. We can quickly infer that it is a query, as when executing this method, we would simply go to some information source and obtain a set of addresses in an array format. Let's look at the second example, in which we would invoke a method called convert. This would receive a parameter of type mp3 file and return a data type more of an interface type called ifile, which would be an interface of a file to perform some type of conversion. Finally, we have a method called create, which would return a data type t, which would be the result of the operation called create. If we look at each of these operations that we have seen in the slides, we can find a pattern in each of them. All these operations return some type of data. Similarly, these operations should not carry out any type of modification as part of the system's state. This is how we can identify that it is a query because some type of data is returned to us. Let's see this in practice in Visual Studio. We are back in Visual Studio and we have our project that we have been working on throughout these lessons. If I asked you at this point which of these methods is a query type operation, surely you would answer me that this method, called save, is precisely the method that is a query as part of our system. Although we have not yet seen the command type operation, we also have a command here, as we will see these of the commands a little later. But being objective with this code that we have, the reality is that if we see the method called save, we see that as part of our system, we are carrying out a change in the state of the system. We are carrying out the writing of certain records. So, this method really should not be a query, because it is executing certain operations that modify the state of the system. On the other hand, if we review our method called read, here no type of modification is quickly carried out in the system. So, basically, we would have to convert this read method to a type or a query type operation. How can we do this? Well, remember that all query type operations return some type of data. We, to return the data in this specific method, are using the invocation of an event, so we can change the result of the set of rows that are returned as part of this method. We can indicate that we want this method to return a list of people. And also, once we have obtained this set of rows that are part of the CSV file, we will simply do a return records so that this set of rows is returned as part of this method. Similarly, we can quickly take advantage to change the name of the parameter that is not very descriptive. It is called ID, and we can quickly change it through this rename option. We will rename it to a name, for example, file ID, so that it is more descriptive. In this way, when someone reads the method definition, they will know that they will read some information or a set of records from certain people. This will be done from a field ID that we provide as part of this method. Finally, what do we do with this trigger, this event that we have at the moment as part of the code? Well, we will solve this more effectively when we see the section on commands in the following lesson. Commands are operations that carry out some kind of modification to the system's state, executing an action and never return values, that is, they are declared with a void return type. Here we have some examples of commands. First, we have this command called save, which we can guess receives some customer, a customer entity, and carries out the saving of information. Notice that we are not returning anything as part of this method, so this is how we can identify that it is a command. Let's look at another example. We have here a method called log, which receives some type of data t, which is ultimately a message, and similarly, we are not returning anything because it is the execution of an operation that modifies the system's state. Finally, we have this operation called delete, which receives a path, a string data type, which is the path of a file, and notice that since it is also carries out some kind of change in the system's state, it does not return anything. This is the difference between a query and a command. A query returns some type of data, while a command should not return any data but should execute certain actions. Let's go back to Visual Studio and examine this in more detail. We are back in Visual Studio and we're going to examine our code or method definitions a bit more. Earlier, we had seen in the slides that we had a method called save, which did not return anything and is very similar to this save method we see here. We had previously said that this method carries out the modification of a system since we are writing a CSV file through a set of people that we have passed as part of this method's parameters. Being an operation that modifies our system, we should not return any information. What can we do? Well, we can indicate that instead of returning a string, it returns absolutely nothing. And finally, to solve this problem of this line where the file path is returned, we will remove it to solve this issue. In this way, we are already indicating that this operation is an operation that will modify the system's state and therefore will not return any information. Now, you might think that with the removal of this line we have here, the system's functionality has been somewhat broken, since before we could easily know the path where the file we were modifying or overwriting was located. If we wanted to solve this issue, we could do it easily. We could declare a new method as part of our file. I will copy and paste this code. And with this piece of code that we have pasted a method called getFilePath, which is a query that will allow us to return a string receiving precisely a file ID, and the same operation is carried out, that is, the combination of the folder path plus the file name. With this method, we could easily, or our API users could easily know the path where the file has been saved. Moreover, if we review the code in more detail at this time, we can see that we have several sections where this part of the code is repeated. Notice that it is repeated once, twice, and if we also review our read method, we see that this part where the combination or creation of this path is repeated 3 times. So we can reuse this new method we have created called getFilePath and replace the places where we are repeating the code. And in this way, we could easily reuse this new method we have created. There are some important points that we must recognize as part of the modifications we have made. First of all, notice that as part of our save method, we are invoking a query as part of this command, so we come to the conclusion that it is okay to invoke queries within our different commands since these queries do not carry out modification as part of the system. What would not follow this pattern is to invoke a command within a query type method. So as a conclusion, we can also indicate that the important thing is that you can quickly and easily identify which methods will be able to execute an action that modifies the system's state and which ones will not, simply by reading the different methods. Now, you should be a little careful with this, since if you start working on a project that someone else has written, they may not be implementing this type or following these software design principles. So, you might find mixed code, like we had at the beginning of this project, and you should know which projects adhere to these principles and which ones do not. So, you don't have any problems when working with these APIs or methods. Finally, let's quickly look at our method called read. Earlier, I had asked you what would happen with this event we had created. Can an event that is part of our method modify the system state? The truth is that if we review the implementation of how this code we have here would be implemented, we will see it in a practical way. Let's go to the program CS file. Let's try to create a new instance of CSV Manager by creating a new instance of CSV Manager. And let's subscribe to the event we created earlier, which is this CSV read one. Notice that the definition created for the event handler is precisely a method that returns nothing and could carry out some type of operation. So, by linking this event to a command, because this is ultimately a command, we would be able to modify the state through this method we are seeing here. Therefore, we should remove this event handler or the call of this event that is part of our method. And since we would no longer be using it as part of this method, we could also remove our event handler to have a cleaner method, which gives us the description of exactly what this method does. It reads an ID from a file and returns a set of people. Let's talk a bit about invalid inputs in our code. We will quickly review our source code, our methods that are part of our class. At this point, I ask you and I want you to analyze this part a bit. Which member that is part of this class do you think could cause problems when used? You might think that file ID, which is part of these two invocations, or well, these three methods that we have here, could cause some kind of problem. But the truth is that an integer as such will never be a null value. It will always have a value. Even when it has a negative value, you will use a value as such. It will never be a null value, because we are working with a primitive data type. Now, you might think that this list of people could give you some kind of problem, and the truth is that it won't. When you carry out the execution of this writeRecords method, if you don't have any records as part of this list, you simply won't write the file, or you can write an empty file. In reality, this set of records doesn't have to represent a problem as such. The property or member that can give us some problems when working with it is this property called CSV folder. Notice the important role of this property. If at any given moment we try to get the path of this folder as such, or rather if we pass an invalid value as part of this property and try to link it with the file ID with the CSV extension, we can have problems, since the file may not exist as part of our file system. And it is very easy for us to fall into these kinds of problems. If we go back to program.cs, I will copy here a piece of code that I have already pre-created, and I will paste it as part of the file. Notice what we are doing here. We are creating a new instance of manager, and immediately we are using or trying to use the method called save. But notice that at no time is it specifying the valid path where that file we are trying to save is located. Therefore, we would have an exception indicating that the file path is not found or that it is an invalid path. And in the framework or in the different frameworks, we can find many classes that will allow us to do this. They will allow us to create instances of the classes and use the methods immediately without a prior check until we execute the application. A good way to deal with these kinds of problems is to establish or create preconditions. As in this case, one of these preconditions would be that the directory we're going to work with, which is this CSV folder property, can never be empty. So let's solve this problem by creating a constructor. Let's indicate public CSV manager. And as part of this parameter, let's indicate that we want a string type parameter called, for example, CSV folder. And then let's indicate this.csv folder is equal to the parameter we have indicated. In this way, we would make sure that the user always passes some data as part of this constructor. Now, the question would be, have we really protected our code through this we have done? Is CSV folder really protected? The problem we have now is that this CSV folder property has a public set. Therefore, we could modify it from outside. Pay attention to what I'm going to do. I'm going back to program.cs. I'm going to replace this code we had previously. As part of the assignment of this CSV folder property, I'm indicating that I want this property to be null. This can happen in systems. You can find, although it may sound very strange, developers who suddenly apply these types of assignments in your code, even if you think it will never happen. We must ensure that this cannot be done. If we can avoid it while writing code, so much the better. How can we do it? let's go to CSV Manager and indicate that we want this set to be private so that we can only modify it as part of this class. And with this, we are already protecting this property so that we cannot assign a null value to it. Let's remove this line that we already solved. A second problem we can have as part of our code is that this CSV folder property can still be null or have an empty value. Many times it will be impossible for us to establish preconditions through type declarations as we did with these private type declarations, as we did with this private one we have here. And instead, we will have to use something called a protection class to protect certain parts of the code so that whoever uses our code does not fall or cannot use the code in an undesired way. And how can we do this? Well, let's modify the constructor a bit. I'm going to paste here a code I already have prepared. And here we are creating precisely a protection class. We are asking if this parameter being passed as part of our users is null or empty. Then we will throw an exception that tells us what the description of what is happening is. In this case, we are indicating that SB folder must be a valid string. And in this way, we ensure that this string always has some value. I ask you now, has this problem we had at the beginning really been solved? Well, we have solved different issues that we have been examining throughout this video, and yet we still have a problem. What would happen if the path, this path that we are passing as part of the constructor, is an invalid path for some reason? Well, we can create a second protection class that precisely deals with this problem. I'm going to replace the constructor. And what I'm going to do here is create a protection class where I basically check that this directory we're using actually exists. And I want to show you here a problem, or more than a problem, a situation in which we are not empathetic many times when writing code. Notice what has happened or what I have written when I am throwing this exception. I am simply indicating that I want a message that says error, and I want to indicate as part of the param_name parameter, in the same way, that text that says error. The problem lies in the fact that our fellow developers, with what we have done, will not have a very clear idea of what is happening or why our system has failed when this condition is not met. Maybe you could think that the condition is very simple, that it is very easy to diagnose why this problem is happening, but imagine that you have a method that carries out some more complex operation and you only show them this error. In those cases, your colleagues would be discouraged. They would have to look at the documentation, they would have to ask the person who wrote the code to see what is happening or why that error is happening and how to solve it. So, we can modify our class to something more descriptive like, for example, indicating that the error is the one we see here, that the path that has been passed as an argument is not valid and that, please, pass a path that does exist. Finally, we indicate which property contains the error, which in this case is CSV folder. In this way, we have dealt with the input part. As much as possible, we must ensure that the inputs are valid. Also, when you know that someone can use your API, your class, or your classes in a way that could cause problems, always remember to leave them some descriptive messages so they know how to solve these issues. It is a good practice to consider both the inputs or preconditions of the system as well as the post-condition of the system, or the different outputs that may arise as part of the invocation of our methods. Let's examine the methods that generate an output as part of our class. We can appreciate that those methods, those operations that return some type of output, are those that return information, in this case, this first method and this second method. For the purposes of this demonstration, I will paste a piece of code that I have already pre-made, which is a bit simpler, but will help us understand what I want to convey as part of this video. And what I want you to think about is whether it really fulfills its purpose. Does it always fulfill this condition of returning a string as part of reading a file? Let's analyze line by line. In the first line, we simply obtain a path as part of this method. In the second line, what we do is read all the text that is part of that path that we had combined and finally return a text. And here, the question is, what would happen if in a given case we passed an ID of a file that was not valid? Notice that what would be done is to combine that path, and here it would try to read all the text of that file. Maybe you could think that as part of this method, externally we would tell users to validate if the string is an empty string, to check if the file has been found or not. The problem with this approach is that the file path or the file itself, for example, may contain empty information or an empty string. That is, under certain conditions, perhaps a user wanted to create this file on purpose with completely blank content, but being an existing or valid file. So, thinking that we are going to have an empty string may not always be the best solution. Maybe you could think that we could return a null as part of the invocation of this method, but this will complicate things a lot. Since this would start to create some distrust in those who use our APIs, because they have to worry or will have to worry about each of the methods that return a data type string. Since it could return a null data in some cases, as in the case we are imagining. And what we really want is for our APIs to be reliable, and that if we say or indicate that we're going to return a string, it is really a string that we're going to return, not that we return a null value. There are several ways to tackle this problem or issue, and we will analyze them from the oldest, which is part of the documentation, to the most modern. The first way is a technique that is even documented in the official Microsoft documentation called tester doer. Tester means to test and doer means to execute, so this technique is called test and execute. This technique indicates that when we have operations that we do not know if they are valid or not, we must divide that operation into two sub-operations. The first operation that performs a Boolean test indicating whether it is valid or not, and the second that carries out the execution part. So, translating this into code, what we can do is create a first method, which will be the one that tests whether the overall operation is valid or not. And in this case, we have created a method called isFileValid, which returns a Boolean value as suggested by this code. We pass the file ID, and here what we do is check if the file we are trying to work with exists or not. The second method we can leave as is, as what we're going to do is, from the outside, we can already use this combination of methods that we have created before. I'm going to copy and paste a part of the code that I have created previously, and it is this one that we see here. Here we are seeing this technique called tester doer, where we carry out the execution of the test method to validate whether or not a file exists, and in the event that the execution of the method is true, it means that we can proceed safely to execute the next method that will carry out the execution of the operation, which in this case is this line where we read the file. The only problem with this approach is that this approach does not work in multi-threaded environments, since someone could delete the file after carrying out the validation of this method, so we would have an error message. That is, we could use this method in one line, and 10 lines later use this method, which could cause an error in case the file has been deleted by someone else, since we are not protecting it in a certain way. Let's look at the second approach. The second approach is a type of check called try-read, and surely you have seen this type of check in some programming languages, like C#, it is quite common. And this second type of check is a type in which you pass some kind of value, such as a string, and try to get a different result like an integer. Here I have a sample code. Surely you will recognize it if you have worked with C# before. With this approach, you define the data that you're going to enter as input of a method. You define the data that will have the output of the method execution, and finally you execute the method, passing the input and passing as a parameter the result, and in this way, in case the conversion is successful, the result will host the result of the operation. We can do something very similar with our code. We will quickly go to our CSV Manager class, and what we're going to do is replace this method with a code that I have already created previously, called try_read_file. We have modified the method a bit. We now return a boolean data type. We receive an input, which in this case is the file ID, and we would store in a string called message what the output is. So we're going to indicate that in case, or well, we start this method indicating that message will be equal to null. And this is because if the execution is not found or the path is not found as part of the structure of our file system, a valid path is not found, then we return a false value and automatically message remains null. But in case it is found or that this file is valid, we will store it in this variable or in this message parameter, the result of the reading, and finally we will return a true value. In this way, we could already tell the user if the reading has been successful or not. How would we use this method? Well, I'm going to replace the code here a bit so you can see. And we have here this section in which we indicate, specify an ID, specify a string, where the result of the file reading will be stored, and finally we use our method in this way. We assign to a variable called exist the result of the method execution. We invoke this method, and finally we will store in our variable called message the result in case a valid file has been found. Now, what is the problem with this approach? Well, the problem is that we do not have an approach that is very easy to use. We have here the definition of several additional variables, and we cannot use the so-called fluid code, in which we can concatenate different operations one after another. In addition to this, we still have the problem that we can get null values as part of our method. We would have to add some validation codes to check if the retrieval has been successful or not. Let's look at one last approach, which is the best way to solve this issue. This approach is called maybe, and this is a concept taken from the functional language F#, which in the F# programming language is called option, but is known as maybe in general. You will even find repositories on GitHub which will talk extensively about this topic, including implementations, Nugget packages that you can install as part of your projects to use some classes related to this concept. This strategy consists of having a collection that returns either no element or only one element within it. Let's go back to our class and replace this method we had created earlier with another one I created earlier. The method is called readFile. What we do in this specific method is that we have replaced the data type that is returned by an array of strings. If no result or valid file is found, we return a string with no element, as we see here. But in case an element is found as part of our files, which is a valid file, this one we are passing as a parameter, then a new array would be returned, but containing the information of the text that we are obtaining from reading that file. In this way, we would have an array of strings containing either 0 or 1 element. This might seem fine at first, but think, with this syntax, we could handle more than 2 elements. We could have 10 elements, for example, that are part of this array we have here. And the worst thing is that whoever uses our API will not be certain of how many elements they may receive when invoking this method. They might think they could receive 5 or 10 different elements, which is not part of what we want to achieve. What we want is for the user to see the definition of this method and know exactly how many elements they should handle or will receive as part of the execution of this method. Unfortunately, there is no native way in the language, in this case C#, to do this. Therefore, we have to create a custom class to handle this. As I mentioned earlier, there are different implementations of this approach that you can find through repositories. In our case, I will show you a simple implementation so that you understand the general functionality. So, as part of my project, I will add a new class called maybe. I will copy and cut a piece of code, which is the implementation of this class called maybe. I will import the missing namespace. I will indicate that I want to use system.collections to fix this problem we have. You can find this class as part of the attached files of this lesson or section. I'll quickly explain this class. We are implementing the interface called enumerable to carry out a set of operations later on. Notice what we are also doing is defining a couple of constructors. The first constructor will create our new instance of the data type we are passing as part of this collection or this new class we have implemented, with no elements. The second constructor creates the new instance we defined earlier, the collection, but this time with the value, in case we pass a parameter. In this case, we are also validating that this value cannot be null, and in case it is null, we simply throw an exception for the user to handle. We also implement these couple of methods that are part of the interface we have implemented, and it is a very simple class to use and define. Let's go back to CSV Manager and replace this method with a new implementation. We have our new method that will return a maybe data type with a generic string. That is, we will return either 0 values or 1 value as part of the execution of this method. Next, we perform the same operations as before, but in this case, if this path is not found, we will return a new empty instance of maybe, and in case we can read the file, we will use the second constructor, in which we passed a piece of data as part of the initialization of this class. And how can we use this new class or implementation we have made? Well, let's quickly go back to program.cs. I will replace the code here. I define the ID I want to query. I also define the variable called message. And finally, I use manager.readFile, to which I will pass the ID I specified earlier. In this way, I can even carry out the concatenation of different methods to obtain a specific result. In this case, I use a method called defaultIfEmpty, so that if no elements are found in the collection or there are 0 elements as we specified, a default value is set, which in this case will be an empty string. And we will use a method called single to obtain that string we specified, either an empty string or the result of reading our file or any element we specified.